Okay, Assalamualaikum and hi everyone. So we continue our chapter 2.2, okay, for atomic structure, okay, quantum mechanics 2.2 in the subtopic of quantum mechanics. Okay, we are going to discuss about the four quantum mechanics, which is NL, M, and S. So the relationship between N and L. So for shell K, okay, if N is equal to 1, the L is equal to 0, the subshell is S. Okay, for example, we have shell L. So shell L have the value of N is equal to 2, and the value permit for L is 0 and 1. So we can have 2S and 2P, and if it's 3, okay, N is equal to 3, the value of L permit value is 0, 1 and 2, so we can have 3, 0, 3S, 3, 1, 3P, 3, 2 is 3D. Then for N is equal to 4, L is equal to 0, 1, 2 and 3, so the value for the subshell available is 4S, 4P and 4D for F. Okay, so magnetic quantum number M. The value of M determines the orientation of orbitals surrounding the nucleus. Okay. So the possible value for M is depend on the value of L. If M is equal to L is equal to 1, so the permit value for M is negative 1, 0, positive 1. So if the value for L is equal to 2, so the permit value for L is negative 2, negative 1, 0, 1 and 2. Okay, so the number of M value indicates the number of orbital in subshell with particular L value. Jadi nilai untuk M ini dia sebenarnya it depends kepada L kita. Okay, alright. So kalau L is equal to 0, M cuma boleh ada satu saja, iaitu 0. So one sub orbital in shell sub S. Okay, and then if L is equal to 1, the permit value for M is negative 1, 0 or positive 1, meaning that we will have 3 orbital in P subshell. Jadi kita ada 3 orbital. Okay, tak apa, nanti kita akan tengok. Alright, kalau kita ada L is equal to 2, so value yang possible untuk M is negative 2, negative 1, 0, positive 1, positive 2. Jadi kita ada 5 orbitals dengan D subshell. Okay, which is dx square y square, dz square, dxy, dxz, and dyz. So relation di antara N, L dan juga M. So the atomic orbital with the same energy, okay, which is the same value of N dan juga L, are referred to as degenerate orbitals. Therefore, there are 2L plus 1 degenerate orbital for each value of L. Jadi kalau kita ada N is equal to 1, L is equal to 0, so subshell yang possible is 1, 0 is 1S. Okay, the value of M kita cuma ada satu saja, okay, iaitu 0. Jadi number of orbital di dalam S is only 1. Okay, only 1 orbital here. Okay, alright. Next. If we have N is equal to 2, okay, if N is equal to 2, L value is 0. So if 2, 0, it is 2S. So for 2S, nilai untuk M cuma kosong. Jadi orbital dia cuma satu, iaitu orbital 2S. Dia cuma ada satu. So this one is 1S. Satu. Okay, if 2, okay, and then L kita is 1, so it is 2P. So if 2P, P ada 3, okay, this is Px, this is Py, this is Pz. So kita ada negative 1, 0 and positive 1 untuk M. So untuk 3P, okay, kita akan ada 3 orbitals, okay, iaitu this one is Px, Py, Pz. Magnetic dia berapa di sini? Negative 1, 0, positive 1. Okay, alright. Last one ialah untuk electron spin quantum number. Jadi electron spin ni adalah it determines the direction of spinning motion of an electron. It is either clockwise or anti-clockwise, which is spinning on its own axis as Earth does. Okay. So the electron spin quantum number has the value of positive half or negative half. Jadi kita ada dua value, iaitu positive half ataupun negative half. So therefore each orbital can accommodate 2 electron. Okay, setiap orbital dia boleh masuk 2 elektron. For example, untuk 1s kita ada orbital 0 sahaja untuk magnetic. Jadi bilangan elektron di dalam 1s kita boleh masuk 2 elektron sahaja. Okay, tadi yang saya dah lukis tu. This one 1s. Jadi ada berapa elektron? Boleh masuk 2. Okay, kalau 2s, dia 2s pun sama juga. Boleh masuk berapa elektron? 2 elektron. Okay, kalau dalam 2p dia boleh masuk, kita ada px, py, pz. Okay, 3 ni. Px, py, pz. Jadi setiap orbital ini boleh masuk 2. Jadi 2, 4, 6. So this one is px, py, pz. Okay, so this one is negative 1, 0, positive 1. Ini untuk, this one is for 2p. Okay. Alright, number of electron in subshell. So let's say n is equal to 2, L is equal to 1. Thus subshell kita bersama dengan 2p. Okay, because when L is equal to 1, it is p orbital. Jadi kalau p orbital, okay, kita ada magnetic negative 1, 0, positive 1. So kita ada 3 degenerate p orbital. So cara kita nak cari bilangan degenerate orbital is 2L plus 1. 2 times 1 is 2 plus 1. So it's equal to 3 orbital. So maximum number of electron in 2p orbital is 3 times 2 electron, which is kita boleh masuk 6 electrons. Okay, alright. So number of electron in a subshell, each atomic orbital can only accommodate maximum of 2 electron. Jadi setiap atomic orbital dia boleh masuk 2 electron. Jadi kalau subshell kita ada S, jadi S dia cuma boleh masuk 2 elektron. Kalau P 6. Kenapa P 6? Because P ada Px, Py dan juga Pz. Kalau D maksimum 10 elektron. Kenapa 10 elektron? Because dia ada 5 subshell, okay? Dia ada 5 orbitals. Jadi 5 orbital ini 5 kali 2 kita boleh masuk 10 elektron. Macam mana kita dapat 5 ni? Okay. Yang ni tadi P X, this is Py, this is Pz. Okay, Px, Py, Pz. Okay, kalau S satu saja, jadi kat sini boleh masuk 2 aja. Okay, this one 2, 4, 6. Okay, kalau yang ini 5, 1, 2, 3, 4, 5. Okay, so this one 2, 4, 6, 8, 10. Okay, ini kita ada daripada negative 2, negative 1, 0, positive 1, positive 2. This one is negative 1, 0, positive 1. This one kita ada 0 saja. Okay, so ini P ni kita ada orbital P lah. This one is orbital D, this one orbital P, this is orbital S. Okay, alright. So bilangan elektron di dalam energy level, okay, the maximum number of electron in a particular energy level and is given by the expression. Maximum number dia 2n square, okay. Pada n sama dengan 1, okay, 2 darab 1 kuasa 2, jadi 2 darab 1, 2, okay. Kalau 2n2, 2 square is 4, 2 times 4 is 8, okay. Kalau 3, okay, 3 times 3 square, okay, 3 square 9, 9 kali 2, 18, okay, alright. So kalau L, okay, kita tengok di sini, okay, kita ada N is equal to 2, jadi L yang possible is L is equal to 0 dan juga berapa? 1, okay, alright. So magnetic yang possible cuma 0. Jadi spin kita positive half, negative half. Okay. So kalau untuk 2, okay, 2L is equal to 1. Jadi magnetic kita is negative 1, 0, positive 1. So spin cuma berapa? Plus minus half, plus minus half, plus minus half, plus minus half. Okay. Alright. Next. So complete the table. Okay. So katalah kita ada shell K and kita is equal to 1. Jadi L is equal to 0. Okay. N tak boleh mula daripada 0. N must start from 1. And then orbital, okay, orbital notation kita adalah 1s. Jadi magnetic kita is 0. So number of degenerate orbital is 1. Number of electron is 2. So number of electron, okay. Nanti kita akan tengok number of electron later. Okay. When L, Kn is equal to 2, L is equal to 0 and 1. So if 2, 0 is 2s, 2p. So magnetic is 0. The magnetic is negative 1, 0, positive 1. Okay. Number of degenerate orbital, kalau 2s is 1, kalau 2p kita ada 3. Okay. And then untuk n is equal to 3, the value of L is 0, 1, 2. Okay. And then the orbital notation is 3, 0 is 3s, 3, 1 is 3p, 3, 2 is 3d. And untuk m kita ada 0, okay. Negative 1, 0, positive 1. Untuk 3d kita ada negative 1, negative 2, negative 1, 0, okay, positive 1, positive 2. So number of degenerate orbital untuk 3s is 1, untuk 3p is 3, for 3d is 5. Okay, we have 5. And then number of electrons. So number of electron 2, okay, 2s 2, 2p is 6. Okay. 3s is 2, 3p is 3, 3d is 10. So 2 plus 2, okay, this one is total number is 2, okay, 2 plus 6 is 8, and untuk m, okay, orbital shell m, 2 plus 6 plus 10, 18. Okay, inilah yang relates dengan electron configuration masa kita belajar dekat sekolah dulu. Okay, kita tulis 288, 2818. Okay, alright. So ini cara kita dapat bilangan itu. Right, so tengok example di sini. Look at the example. State whether or not each of the following symbols is an acceptable design for an orbital, atomic orbital. Explain the unacceptable symbol. Okay, 2D. Is 2D acceptable or not acceptable? Okay, boleh ke tidak wujud? So 2D tidak boleh. Okay, bila n is equal to 2, L is equal to 2, which is not possible. Kenapa? Because when n is equal to 2, the allowed value of L is only 0 dan 1 that represent 2s and 2p only, meaning that we won't have 2d orbital. Okay, 3p, when n is equal to 3, okay, L is equal to 1. So, acceptable. Kenapa? Because, okay, bila n is equal to 3, the possible value for L is 0 and 1. Okay, 7s acceptable. Okay, 7s is acceptable, boleh diterima. Okay, another one. Explain why of the following set of quantum number are unacceptable. Okay, in an atom. Okay, so when n is equal to 2, L is equal to 1, magnetic is negative 1, spin is 1. Is it acceptable or not acceptable? So the answer is no. Okay, because S tidak boleh jadi 1. Tapi kalau untuk for N, okay, N dengan L is possible. Okay. Untuk S tidak boleh. S spin mesti positive half or negative half. Okay. B. N is equal to 3. L is equal to negative 1. Magnetic is equal to 2. Okay. And spin is equal to positive half. Okay. So, boleh ke tidak boleh? The answer is when n is equal to 3, okay, bila n is equal to 3, the allowed value untuk L is only 0, 1 and 2. Therefore, okay, L negative 1 is not acceptable. Okay, sebab apa? L dia mesti bermula daripada 0, 1 and 2. L tak boleh mula daripada negatif. Okay, tapi kalau magnetic boleh. Tapi magnetic bolehlah di sini, magnetic dia letak 2. Okay, so bila nilai L tak boleh, thus untuk magnetic quantum number ini tidak boleh. Okay, set of quantum number ini tidak diterima B. Give the value of L and M untuk 3P dan 4D. Jadi untuk 3P, L there is equal to 1. Magnetic possible value is -1, 0 and +1. Untuk 4D, okay, 4D, L is equal to 2. So the magnetic is -2, -1, 0, +1 and +2. Okay, so this is the activity. Write the orbital in terms of SPDF notation, which are represented by the following quantum numbers. Okay, when n is equal to 2, L is equal to 0. So it is, okay, it is 2s. Okay, it is 2s. So 3, 2, 3d. Okay, 5, 1, 5p. Okay, alright. Which of the following quantum number are allowed? Okay, so this one you can try on your own. Okay, boleh cuba. Right, next. Set of quantum number to determine the location of an atom, NLF, and LMS. The example for S1, meaning that it is for n is equal to 4, L is equal to 0, magnetic 0, spin positive half. For quantum number of 2s orbital are n is equal to 2, L is equal to 0, magnetic 0, spin positive or negative half. And set of quantum number NLMS dia adalah 200 positive half or 200 negative half. So as a conclusion, the principal quantum number n kita, definition, okay, kita tengok di sini. Principal quantum number dia adalah determine the energy size of an orbital, which is the value is 1, 2 and 3. Azimuthal quantum number L, with it will define the shape of orbital. So the permit value for L is 0, 1, 2 until n-1. Magnetic quantum number M define the orientation of orbital, which is the value is -L, okay, 0 until +L. And the spin quantum number cuma ada dua value. It defines the direction of an electron, okay, rotate on its own axis, okay, which is positive half or negative half. Alright, so that's all, end of part 2. Thank you, class.